Okay, I'm Kneschke from MySQL, which got bought up by Sun, got bought up by Oracle, got bought up, I don't know yet. But I still say that I'm working for MySQL because it's a lot more stable than changing company names. Okay, I actually work for the MySQL Enterprise Tools team, so any one of you works in a company that has MySQL subscription, you may use something that I worked on. And most of my time is all around MySQL Proxy, which is also part of the Enterprise Tools package, just as one of the components where we actually use it for something interesting. This talk here is an extended version and a remake of the talk that I gave at the MySQL User conference in April. So please raise your hand if you attended the MySQL User conference. Okay, the usual suspects. That's okay. So for everyone else, this is all brand new and you don't know that I've given this talk at the user conference. Who of you has used MySQL Proxy? Okay. Okay. Yeah,
and nobody will know because I don't think I videoed it at the conference, so it's good that you're doing it again.
I heard that you wrote a book about it.
About Proxy? No. There is a chapter in the book about Proxy.
It's a cookbook. I heard it. I read a chapter.
Well, you mean this book?
I don't know if it's in there.
This is the MySQL Administrator's Bible. Which I did
it's just one page.
No, it's 800. It's 800 pages. So, but, you know, I already did my talk, so I'll let you do yours.
Okay. So, as not everyone has used MySQL Proxy, I will give a bit of overview of what MySQL Proxy is. It's now about, let me calculate it, 2.5 years old. It started pretty much in February 2007 as a weekend project. So it was a 2-day hack to see if something is possible, something that I actually didn't want to do because I actually intended something completely different, but this was the outcome of it, that one weekend. That I was able to decode and encode the MySQL protocol and actually forward it on 2 sockets and then being able to intercept and inject stuff in there. So something that was not really possible before, but it's part of several other implementations of the same idea right afterwards. Before, you were pretty much limited to what you could do with the MySQL protocol. So you had clients on one side, so your application basically, and you had the MySQL server. And the MySQL server is not so well known for being, that's one word. Yeah, polite is one way, or flexible, that's the other one. So there are so many ideas about, oh, it would be so nice if I wouldn't have to change my application just to let it actually write to another database, just for testing. Because usually in the real world, there's more than one person working on something. So there's the DBAs on one side, and then developers on the other side. And usually those two groups don't talk to each other. It's just how it is. And so if the DBAs figure out that the developers are doing something crazy, like, we don't need indexes and normalization is for whims and so on, then DBAs can only scream. So they can only use their large device and actually convince them, or they can scream, but they can't really change the code. So they were limited. And so then you have to go into development redesigns and all that kind of stuff. So there was no tool to actually change something on the fly without having to go to developers and educate them. There was no something on the server side. There could have been, but yeah, some things are not as easy in MySQL as you want. And so one of the ways was actually writing something that sits in the middle, which is not the MySQL server, not the application, where you can tweak everything that's going on the network. That means everything. And if possible, the whole thing should be transparent. As good as possible. It's not, there are some limitations in the end, but MySQL Proxy itself is nicely transparent so that the application doesn't really see the too large difference between if it talks to the proxy or the MySQL server. So, with the MySQL proxy at hand, you can do a bunch of stuff. The most basic stuff, you can log everything that's going on. That's not really interesting. You could use TCP dump for that to get pretty much the same picture. Which is logging, auditing, tracking queries, execution times, that you can make your histograms, that you have your profile of which queries executed by what user, taking how much time, so that you can do quota stuff, so that you actually track, okay, which user is doing the worst queries in his lifetime, so gets the, I don't know, the top employee of the month, so this kind of stuff. So a monthly report where you, yeah, I don't know, vote for someone who's buying the next box of ice cream or something like that. So just getting access to this information in a flexible fashion. This is just reading stuff, which is okay, it's a start. Something you have the same way in the general log on the MySQL server side, just it writes a disk and you can't really parse it nicely. So the proxy in the middle, application talks to the proxy, now you have access to everything that's going on. You can get microseconds or milliseconds, whatever you want, and track what's going on. And you can do your data warehousing on your data that's going through. That's the easy part. It gets more interesting if you extend it by, okay, I have more than one backend, so I start routing queries to different MySQL servers, so that you have some kind of logic that allows you to pick the MySQL server, so that you can do load balancing, or you can do failover, or that you can do, not yet, but perhaps if you invest some more time, do sharding on that level in a dynamic fashion. So those are what you can do, or which can be based on this platform that we have here. More interesting, and that's where I have most of my fun, is the part about rewriting queries and injecting queries. And injection, basically, I think everyone knows SQL injection. Yeah, it's usually the bad stuff. And we are a man in the middle. Every proxy is a man in the middle. And so usually it has this very bad touch. And I'm advocating for changing this bad touch into, there's also a good man in the middle, because it allows you to actually do some really interesting stuff around the queries. Like actually doing performance analysis on your queries while you execute them in a transparent way, so that the application doesn't have to be changed to do the performance tracking of the queries. Simple idea. If you figure out that your query runs, let's say, 500 milliseconds, the easiest you can do is actually fire in an explain for this query and store it somewhere when it happens. Instead of taking your slow query log and then after a month trying to get an explain for the queries that you executed a month ago. Because that usually means that your caches are not the same, that your execution times are different, your data set is different. So it's a lot better if you can do it when it actually happens. And so what you can do with the MySQL Proxy is injecting query in the connection that the user has opened, without letting the user actually see what's going on. So the query comes in, proxy sees it, returns the result set, and injects another query in the connection transparently, handles the result set, and then returns the connection back to the client actually. This kind of histogram and auto-explain is all part of the distribution. So there are actually examples containing all that stuff. I'm just trying to summarize them so that you have an idea what's already possible on that side. So if you take it all together, you have routing, you have query injection, you have a lot of tools in there allowing you to be as flexible as you want to be on the DBA side. So you don't have to ask your developers anymore to actually change, please do this for me. Instead you just say, okay, you do whatever you want, I will just rewrite your query on the fly to do what I want them to do. You have regex, you have queries, you just rewrite them and then just make up the result set so that and the client is happy afterwards. You can generate your online views, you can materialize stuff, you can do a bunch of stuff. So everything that you can do at that level just by playing with the queries that you forward. You don't have to care about the protocol stuff. All that is hidden, that's what the proxy takes care about, and which is hiding all that nasty stuff from you. Now what is taught? What I want to talk about here is not about what MySQL Proxy can do, because that's what you have on the website. What I want to do is showing you what's under the cover. So for now we looked at how a pervert would see it. Now we want to look at how a frog would see it. For instance, is FrOSCon. So from the bottom up, so everything that you have here in the package is the MySQL Proxy. So the MySQL Proxy is in the end a name for a combination of different things. I hope you can see the full picture. Fine. From the bottom up, there are a bunch of libraries. First of all, there's the Lua, our scripting language that we use. Who of you has written Lua already? Okay, handful. Who of you has played World of Warcraft? Okay, that's okay, just one. Come on.
Well, that's because the ones who really are into it are at home playing it right
Yeah,
now. They would not waste a Saturday coming to a technical conference. That's World of Warcraft time.
Yeah, okay. That's right. Just because World of Warcraft is everything that's customization and World of Warcraft is written in Lua. So all the kiddies that were something like 5 years ago, they will not learn PHP or Perl, they all know Lua already. And world domination on Lua will come. That's a long way. No, Lua is a scripting language which is easy to embed and very flexible and is heavily used in the gaming industry. Just because it's very easy to embed and good to read and very flexible, and you can easily customize it for your needs, which is the main thing. And it's fast, which is important for the gaming industry. So they haven't used Perl, they haven't used PHP. Sometimes they use Python, but in general they use Lua for that very same reason. So Lua is our scripting language because in the end, everything that I write as libraries is easy to consume for me, but not really easy to consume for the average DBA. So scripting makes it easier to customize stuff. We have two libraries we will look into a bit more in detail, which is the protocol library and the chassis. We get into that very soon. And then based on those core libraries, we build our state engine, which is basically the network lifecycle handling. And then we have plugins which then use that facility to implement whatever you want to implement based on that. So everything is nicely stacked, plugin based, and in the end glued together by a scripting layer so that you can actually expose your own functionality without having to write code. The MySQL Proxy is the whole package if you load those two plugins. So the proxy plugin, which is forwarding connections, and the admin plugin, which actually allows you to log into the MySQL Proxy itself to do administrative commands. Both you do the MySQL protocol, so you just use your MySQL client and use part. Okay. You just use another port and then you log in into the admin plugin and then can configure stuff at runtime in the proxy. So our focus is getting into the details. So let's actually start with our libraries. The most basic one is just a common library. The chassis is like in the car, so the most basic stuff in the car that you always need is the chassis and some tires. And then the rest is pretty flexible when it comes to style and what kind of stuff you want to put into the car. But all the cars need the same stuff, and for programs, they all need pretty much a similar thing all the time, and it's logging. So they want to log something to syslog file and so on. They need the command line interface, so get up stuff and nicely handle stuff. They need config files. If possible, the config option should match the command line. so that you don't have two different ways of specifying stuff. There should be some kind of system behind it. So that's what the chassis is doing. It's pretty flexible, independent of the whole MySQL proxy stuff. So in case you write your own applications that all need this basic functionality, you may just want to look into it and use it. So we built our stuff based on glib, and this is just a nice collection of making all the glib stuff nice and easy to handle for us. So that's not the interesting part. The chassis is nice. We will sometimes see it in the Lua scripting layer when we want to redirect our logging, but otherwise you actually don't see it. More interesting is the whole protocol part, because there is all the interesting stuff going on. And the protocol itself is more or less documented in the MySQL Porch. If you take the slides from the download page, and you can actually click on the link and you see the full one. But the documentation is there. It's a wiki, which is more or less describes the state it is in. So it is documented by the guys who actually think they want to document it. So it's not the perfect 100% correct documentation. The perfect 100% correct documentation is in the source code. And nowhere else. So some of the parts of the MySQL protocol are nicely documented in header files, which is very good, sometimes very good to read, especially if you want to go into the binary logs. But some other parts are just, if you don't know it, and you don't know the bugs that are related to it, then you just run into them, which is very nice because every connected developer, so we provide connectors for Perl, PHP, Ruby, and pretty much everything. Everyone runs into the same problems again and again because they implement the protocol again. And yeah, that's another long story. Okay, now looking at the documentation you have there, you have the normal MySQL client protocol. So it is what the client talks to the server. It's homegrown, so it's more or less the same since the early versions of MySQL. So it has some history, and the history always carries a lot of, there are no nice ways to say it. So that's what I mean here by creativity in the implementation. There's a bunch of stuff you don't want to know in the protocol. And but we have to talk about it. Because that's the stuff that I just want to convince you that you don't want to care about it. So that's one of the examples of what you don't want to know, is how to encode an integer number in the MySQL protocol. And it's, if you take the normal MySQL protocol, so you send a query, you get the result back. Numbers, if you don't do anything special, are encoded as strings, as length encoded strings. So that's why we have here in the first case our length specifier 4 bytes that are following, and then our numbers in hex in that case. So that's 31 is the hex number 4, the ASCII character number 1. Which is okay, it's in a very compact form of actually encoding integers that you first convert into strings and then send them over the network. Okay, that's something that was changed in later versions. So in MySQL 4.1 there's a pre-paired statement support that introduced a new way of sending numbers over the network, which is pretty straightforward. So this is just a 4-byte version of 1, 2, 3, 4, just a hex number, 4 bytes, and it's just binary encoded over network, which is fine. This is what you would expect. So you know, okay, if it's a 4-byte integer, then you just decide on what byte first and you send it over network. Because now you don't have to parse it, you just take it back and then the machine will actually understand what it is. Just some bit shifting and you have it always in the right direction. But as different developers worked on the protocol, they had different ideas on how to encode numbers. So strings and binary are the two easiest versions of doing it. But luckily they had a third idea, and which is the idea of let's actually make the protocol space efficient, which is a good idea. Yeah, so instead of trying to say, okay, I don't want to invent different types for different integer types. So here's a 4-byte one. MySQL has many integer types, and you see some of them in the create table statement, but there are more than that underneath. So there's 1 byte, 2 byte, 3 byte, 4 byte, 6 byte, and 8 byte, depending on where you what you're trying to store. And to actually compress them in a nice way, there's also another way, which is length encoded integer numbers. There are different protocols having a similar idea. Here, the first byte is actually an indicator, okay, this is now a 2 byte. Actually, this is wrong, this example, but it doesn't matter.
If we don't want to know, you can skip the slide.
Actually, so the point is, there's also a length encoded integer variant. So depending on what the first byte is, you know how many bytes you expect afterwards. So if it's just 1 byte, then you know, okay, it's 1 byte. If the number is less than 250, then you know it's 1 byte. So up to 0 to 250, it's stored in 1 byte. If it is something between 250 and 255, then it is 1 or many bytes. So depending on where in the protocol you are, you have different ways of encoding integers. And I just say, come on, it's just an integer, it's no magic, it's just the most basic form of storing numbers. Unless you don't want to know it, all this is hidden from you by just encoder libraries. I just wanted to convince you that you never look into it, that you just use it. So using those very basic libraries, which are encoding and decoding the different parts of the MySQL protocol. There's for sure the MySQL Proxy you could use, but for two different aspects of the same thing, the same libraries can be used to work on the different files that you have in the MySQL setup. So the most basic one is just a very similar application to MySQL binlog. So it can take bin logs and actually dump the content. But it can do a bit more, so it is actually giving you access to everything that's in the bin log. MySQL binlog, the tool that you have in the distribution, is hiding you some part of the information. Up to the time that I wrote this application, MySQL binlog was basically hiding you everything about our row-based replication events. Something that was introduced to MySQL 5.1, which is pretty neat because it just sends the delta of a change. So if you do an update on a field, it only says, okay, what's the field number in the table, and what was the original value, what is the new value, and then that's it. So it doesn't change send queries anymore.
How is that different from MySQL binlog, like dash, I think it's bin hex or something?
And the hex stuff just gives you the hex string, and now your
But
brain has to...
But you get the query too. There's one option where you get the query to MySQL binlog.
Yeah, that's what they added after I showed them how they could do it.
Oh, okay. So you did binlog dump first?
Yes.
Oh, because I was like, why would you do binlog dump if they already have binlog? But
they didn't have it, and then the support team came to me and said, actually they complained to the replication team, and they said, oh, it's too tricky. And then
you did it and got a raise.
And complained, and yeah. So now that way it went into the MySQL binlog. Come on. So otherwise there would be now no way of decoding those very nice events, so that you have actually no way of what's going in there, which is tricky if you get a broken binlog and have to figure out what's in there, and you have no way to decode it other than using your brain to read binary streams of data. Okay, so MySQL binlog was the starting point, and it got a bit more interesting. So let's take a look at what is perhaps the more interesting version of it. This is the point where, as Giuseppe said it, where it breaks. So
it becomes more interesting.
Yeah. So this is these are the examples that I prepared for the user conference. And when I tried them again, it didn't work. It's nice if you don't touch something for half a year, and then for some reason after half a year it doesn't work anymore. But that is not our problem here. Okay, so show me the code. This is better. So this is Lua. So it doesn't should not be too confusing. It's just a normal language. Has some basic object-oriented functions, and you can write them object-oriented. So here, just to describe it, we open our binlog in the writing mode. Enters our binlog is our binlog object, and then we append a few events to the binlog. So there's some internal structure that you have to know about, but that's pretty much how we create our test binlog. And that's the main difference. Up to now, you could never create binlogs yourself. So there was no way that you could create your own binlogs. So you could not just, for testing or for reproducing stuff, or for actually doing some interesting stuff that I will show at the end, you couldn't create binlogs. There was no library to do that. So if you hadn't written your own, there was no way. So the libraries from the previous slide and this Lua wrapper around it, and the code allows you now to create your own binlogs, and all of them start with the same stuff, so they always have a so-called format description event. So we are nice, we pretend that we are not a MySQL server, so actually say that we are MySQL Proxy. It's always nice if you do something that's unexpected. So there's some version matching going on the slave side. And if you give it the wrong version, then it tries to fix stuff. And so that's a nice way to trigger that. And then we just, here's an example. Create some query events, just an example. And then close the whole thing, we're done. Okay? So that was just, I don't want to spend too much time in looking at code. But I want to, let's see, I think that's it. That's a short time. But instead I want to get a bit further on that without filtering, because that's more interesting than creating stuff. Because usually you have a binlog, and then you have the point of, we have to remove some data from the binlog. Either if you want to insert the whole binlog in a new server, so you want to have all the changes, but changes to this one table, to this one database, from a given timestamp, whatever. You want to filter on some condition and create a new binlog that you then want to insert into the server. There was also really no real flexible way of doing it. So instead of providing you the tool that does it, I just give you the library, some scripting, and then the rest is just walking over your binlog and creating a new binlog based on the old data. So here in this example, I have an incoming and an outgoing file, two binlogs. I read from one and I write to another. Then iterate over the binlog. Then what the next function is doing, it gives me the next event. And then I just walk over it. And depending on some condition, I either append it or I ignore the statement, so the event from my new binlog. In this case, I actually tokenize the different statements, and if it's an alter statement, then I actually remove it. So that way, some user did an alter statement in your normal operation, and that way trash your whole database. You can just take the binlog, create a new binlog based on that, removing everything that was an alter statement, and just insert the binlog as part of your replay after, as part of the restore. And so you have the same data as before, but you actually don't have this whatever. So your statement you figured out is the bad one, the old statement. You can filter on whatever you like. So you can filter on timestamps, you can filter on queries if they contain some other content, whatever you want. So there's no limitation on that. This is just scripting code, and you can tweak it for your needs. So that was basically the script version of MySQL Window. So instead of doing it all in C, completely hard-coded, the Lua stuff is breaking it up into libraries, modules, and then you just glue it together as you need it. The whole thing is focused on flexibility and simplicity, instead of just having one tool where you then have to recompile everything or provide bug reports that you at some point in time give the feature and so on. The other one is MySQL MySQL. There's no replacement for that one, which is decoding the FRM files and the MySQL data files. So MySQL data files are very simple in structure, but you can't decode the structure without first knowing about the FRM files. FRM files, your table structure that you have for all of your tables, independent of what kind of storage engine you use. So they contain the structure, so column names and column sizes and so on, and where your indexes are and foreign keys, all that is stored in the FRM files. Now, FRM files, I just have to show it. So this is how the internals of the FRM actually look like. It's binary data of some kind, some version indicator, and then a lot of numbers. Those are not too interesting. I think the first one that's interesting is this little gem. So all the FRM files actually contain the MySQL version that you were created from. Who of you have ever tried to update the MySQL database from 4.0 to 4.1 to 5.0 to 5.1? So any of those steps.
Oh, I was like, all at once, that's a lot.
So, and who of you have not run into problems? You're lucky. Or in case you just use MySQL dump and then replayed it from dump, then you're fine. But if you actually just copy the files over, then you have a pretty good chance of, I would say, 10% that you run into problems. So 90% is just fine. So just because you don't use anything special. But in the 10% case, you have to know the upgrade procedure to actually move forward. So like decimal tables, they're using new decimal at that point, character set stuff came in for 1, and similar other stuff joining a later version. So, but there was no way in the information schema or in other ways to figure out on what MySQL version table was created. So this information is not exposed because it would be useful. But you can actually just check, okay, was this FRM file created in a new version so I don't have to upgrade it? Or do I know, okay, this was a faulty version, I want to do some special checks on the table to actually move it forward or run check table or something similar. So this is the first little gem in there. So it contains the version number that created it. But more interesting is this little gem. And let it come to you a bit. So what might it be? So what might screens be? And what might they be good for if you have a table definition? So if you do create table, yeah, then it writes all the column information. That's what we have underneath. That's what we have here. There's some columns, how many columns we have, and what kind of type, and our record position in the in the data file, and so on. It's all stored here. It's all fine. That's one part. But what are screens for? I mean, what could be the use of screens? Have you ever seen screens in your SQL? Anyway.
20 years ago?
Giuseppe, you have seen it. Yes, 20 years ago, well, let me look through the room. Giuseppe, you might be...
I was 10 when I was.
At that time, you have seen it.
I'm sure it would help.
Yeah, back at the time when screens were still green and black, there were screens. So you had just 80-25 screens, and you could put fields in there, and you could select them, and they could contain data and so on. And that wonderful information is still stored in your FLM files. So in case you go back in time and want to do it again, I think if you have a, just thinking about it, if you have a mobile phone, I think they're still already too powerful to simulate one of those old boxes. But the information is still in here. So we have our rows and columns needed, so it is 80-22, our screen resolution that we have. And then we have our starting row, how many fields we have on this screen, because we can have multiple screens, like you have it in Excel and so on. And then we have positions, and which row we have our starting position for that field. I don't know why it is still written. It's written all the time in the create table. It's never read. So the reading code is removed, but the writing code is still there. For no good reason. But everything is still calculated, so all the information about where to place stuff on the screen is still used. Which brings my little challenge, and I'm always looking for someone to actually do it, to make this useful. So, I don't know, this is not too flexible, so you can't do everything in there. But think about your average web page, or whatever application you have. You always need some kind of XY information on where to store stuff. So if you find a way to use this information for good, please hack it together. So and make it useful again, because this little gem is in there and containing, it takes your CPU time and everything, but it's not used. It's really just there. So why is it there? So let's make the full story. The code that's used here is from 20 years ago. So FRM files are from the time that Monty worked on a product called Unirec, which was using ISIN files, which was state-of-the-art at that time. And that was the time when you had 80-20 screens. So that was his way of encoding information in there. And as the format of these files has never changed, and the code never changed that wrote it, information is still maintained in there. So this is your way of making your screens up. So I don't know, if you have a mobile phone without too many UI stuff, you could place your 80-20 screen on there. Or something that I don't know what's good for. So just on that side. So the other interesting part here is, I hope you can see it. Can you see the last? Whatever. I can't really see it. There it is. So it also contains the storage engine name. And so based on the same libraries and everything that we have just talked about, I wrote a storage engine which is executing Lua's code instead of actually reading and writing stuff. And this is just one of my test files to actually try it out. And I actually use it to have a binlog storage engine so that I can actually select the binlog files. Something you can't do right now, you can only show the binlog events, but you can't really filter them on your own conditions. And with the libraries I talked about and the Lua script, the Lua storage engine, I was just being able to actually select my binlog files. So I can actually select based on query text, timestamps, and join them against other information and so on. So that's a part where it's important to actually split it out into smaller components. So instead of having one finalized binary like the MySQL server, which has everything, so it's one big blob, it's one big thing, and it only exposes information that it wants to expose through show commands, select commands, and so on. My way is actually going the other way, split everything into libraries, then combine the libraries into one application, put plugins on top, and adding a scripting layer to use the different components that we have to do what you want to do, which is a huge difference to what we want you to do with our stuff. So it gives you the power again to work on the stuff. Binlogs is one part. My ISM files is not too interesting, but FRM files is a nice starter there, and protocol stuff in general. That's the one I showed. So, but if you can read binlogs, and if you can write binlogs, and you can filter, that's what I already showed, there's a bunch of more stuff you can do, because in the end, there's just the list of feature requests of what we want, what users ask, the replication team, let's do this feature, let's do that. And usually it takes quite a while until something is implemented actually makes it into GA release. And part of it is because everything is waiting on our side. So if you want to do something like merging binlogs, so taking two binlogs from two independent servers like you have in a sharded environment, merge them into one binlog so that you can actually replay them into your reporting server or whatever. Okay. And there's no way to do it. So there's just because no one implemented it yet. So, but in the end, no one has to implement it. All you need is to take the code from the MySQL server, split it out, put it into libraries, put an interface around it, and then let someone else do it. And that's what I did. So, based on the libraries we just shown, to read and write and filter stuff, you can also just take two binlogs and merge them on their timestamp and create a new binlog from it. So instead of just having one binlog, writing one binlog, you just open two. And just take the events from the two binlogs and put it into a new one, so that way you have now one binlog that contains all the content from the two binlogs, and that way you have an easy way to merge your stuff together. Not possible without that. So you can't have two masters for one slave. And that's one way to implement something like that.
That's assuming you're making use of NTP, because if you are...
It doesn't matter too much. So, because in the end, the two logs are independent. That's the first condition that I use. So even if the timestamps don't match too much, doesn't matter. The data is still fine because it's independent. As long as it's still correct for each of the servers. So if you merge them, it's still correct afterwards. Sure, you always want to use NTP. There's no question about that. Always. It's lots of what do you do? It's really over, or do I still have 5 minutes?
You have 10 seconds.
10 seconds, okay. That's 10 seconds each way. So, I think that's 16. Just give me something, and I will.
Let me see. It's not up to me.
I think it was an hour.
We have a 15-minute break.
Okay. Okay, so I will make it a bit shorter.
Still have 15 minutes.
Okay, so I'll give you a bit more. That was actually quite funny. So being in the US and actually trying to explain what toolbox means. But it's one of those nice words that just makes sense in some cases, so it just works. And then it's hard to find a good English translation for it. So for Sherry.
Also for me, thank you.
And Colin didn't know.
So toolbox, so you all know Formula 1, right? So you all know the cars and shake around in circles. And whenever they stop, they need some new gas line. So they have to on high pressure, put the gasoline into the car.
Right.
And that's what the term means. So Druck is pressure and Betankung is the way of getting it in there. So getting a lot of stuff into your engine as fast as possible with no regrets. So if you pull it off too early, then it starts burning and this kind of stuff. And that's the idea behind what I try to implement on that side. Because there is usually a good challenge of, if you set up your first database and you want to get data into it, there are several ways of doing it. So you can do single inserts, which is not so fast. You can do multi-row inserts, which is another way of getting it in there, which is a lot faster than single inserts. Then you can use transactions if you use ADB to group it nicely into nice chunks, not too large, not too small. But the other way is getting rid of all the SQL parsing. So just using row-based replication, what we have in MySQL 1, which is a binary encoded way of encoding rows that you insert into something or that you update or delete. Just using row-based replication to actually push data into a new server. So that way you remove the whole parsing part. So you don't have to, no one has to parse the SQL, your big text block that you send, and verify it. You just give it a digital version of it, as native as possible. And to use it afterwards, so writing bin logs is what I showed already. Row-based replication bin logs are just the same, they just use different events. So it's not too tricky to generate them. Then it just needs some special setup, because what you want to do is you want to make yourself a master. So you want to say, hello, dear slave, I want to send you some data via the replication channel. And to do that, you have to be a master. And the MySQL server doesn't really let you do that. So you can't generate a bin log on the fly and then tell the MySQL server, please, this is your bin log, please send it out to your slaves. So what do we do?
Oh, by the way, I was mistaken. You have still 13 minutes.
13. Okay.
Oh, you thought this was a 30-minute lecture? I thought it was a lecture.
Are you sure about 30? I think 15.
I think 13, so now it's 12 perhaps.
13.
Next starts at
Oh, you started at
16:30.
15. Oh.
So
So what do we do? Let's see. There we go. Bigger again. So what do we do? We just use our proxy. Well, we don't use the proxy itself, we just use a part of it. Just to give you an idea of which parts we use. Yeah, so the whole proxy is the lower end with those two plugins. And instead of using the proxy and the admin plugin, we just use our replicant plugin. And a new plugin, which is the master plugin. And use those two as to simulate a master and a slave that reads something from it. So we use all the libraries, we use all the core, but we just replace the upper part with the new plugin. And those two plugins are now, actually show you how it starts. So here, some setup, don't care about the first part. Here we use our loadout two plugins, master and replicant, because we want to simulate the master side and the client side. We could also use a real MySQL slave there on that side. We set up the replicant so that's the slave to where to fetch stuff from, and then we give it, each of them a script, whatever they want to pretend to be. So the master Lua script is generating bin log events on the fly, and the replicant is just taking them and printing them out. That's what we see here if we start it. So, that's part of the dance. So this is the replicant plugin, which is pulling the stuff from our on-the-fly generated bin logs. So it creates a simple table. We call it a pump because we want to pump data into something. We start our transaction, and then we have our table map event, which is the internal structure of those row-based data. Now, in this case, we are not inserting data, but we update, but the general idea is the same. So here you see how it looks internally. Just fields, the before image, the after image, and how the data is changed from one to the other. Oh no, wait, that's actually, oh, it is in right. So this is just, actually we just insert two rows. I was wrong. So this is one row, the two columns, this is another row, two columns, just in their most native way of encoding them. Because internally, row-based events, they use the same format of representing data as the MySQL server does internally. So there's no conversion needed to get data into it. So all we do here at the end is the XID event is the commit, and then the incident event is just to stop everything. Doesn't matter too much. So that way we have generated our bin log, and I can just show you because it looks like something I've already seen. This is our master. So the master plugin loads the master script, and which is just creating events, pretends to be the MySQL server 5.1.26 in the special MySQL Proxy version, and then it just adds those events into it. And this is how you represent our rows. So it's pretty much straightforward. So there's no special encoding, it's just a table, and then you just feed in the data of what you want to do. Everything covered in transaction, and then we just, the incident event is just one way of stopping the slave from continuing to read stuff. Then we just send it out. So we just provide an iterator. The master plugin actually calls the iterator. We provide all the events, and if we are done, then everything is finished. So that way, we can create data in the most native form for our MySQL slaves, so that we can actually feed our MySQL servers with data as fast as possible in the most native way. The setup is a bit awkward because we misuse the MySQL servers, because we generate our master on the fly, which is generating data on the fly. So it's not really a real master. And the data that we want to insert data into is in reality a slave that's talking to a virtual master. And so we have to use normal slave lens here to get him to fetch all the data that we want to send. It's a bit backwards, but it's one way of using the functionality that we have and all the libraries and the scripting and the proxy to actually move forward and get data into the MySQL server. The one thing I never actually tried was benchmarking it. So the whole thing could be actually a lot slower than the real insert way, but it's more about the idea. It's not about the performs or not. I leave that to someone else. So that was, because the topic here is misuse of the features, and that was one way of misusing it for the greater good. Slave accelerator. It's something that's discussed a few times already. Now I have 5 minutes, thank you. Slave accelerator. I think the name for it is the Oracle algorithm. It has nothing to do with the company, but it's just more about oracling what is going to happen. So if you want to speed up your application, what you should do is selecting rows that you want to update. Because updates have to read rows, that's what the where clause is doing. And if you want to speed that part up, you should just make sure that the rows that you want to update are in the caches. So what you do is, when you insert it into the master, it has some lag before it gets to the slave. So what you do, you just select the same rows that you want to update on the slave side, making sure the caches are hot, In that way, the replication statements which are executed sequentially in a synchronized way are just don't have to read anything from disk because everything is nicely hot in the caches already. So that way you can easily speed up replication on the slave side, but just making sure the data is in the caches. And that the easiest way to make sure they are in the caches is by just selecting them and throwing them away. So you don't care about the data, you just want to make sure they end up in the caches. And there are a few ways, actually just figuring out and talking about something completely different. That's also different. That's nice. Oh, that was a... So I'm talking about something that's actually not on any of the slides here. That's nice. But you could use the proxy to intercept the queries and see, okay, this is going to replicate it. Also open another connection to the slave and select there so the replication gets faster. Wow, there was nothing. Different topic, the stuff that we have on the slide here. Is making replication parallelized. No, that's the wrong word. Making it parallel. So that you actually execute it not in a synchronized single-threaded fashion, but you figure out in some way, and the logic for that is in your scripts, you figure out how your data is independent, and then you just open several connections, and actually split your bin logs into smaller bin logs that you actually push into the slaves. So instead of letting the slave fetch it, you just be active and actually execute the insert statements and update statements on the slave as a client. So there's an external application sitting in the middle, something that is at the far end of the slide. I hope you can see it. Which is, instead of pulling all this stuff, is taking it, splitting it up, and then pushing it into the slaves, allowing it to work in parallel. It only works if the data can be figured out to be independent, which is usually the case if you have, for example, have multiple customers on the same database. Then they usually don't write across database boundaries. That's one way. The other way is what I used here in the example, because they're the ideas from, is Wikipedia, because they only work on language boundaries. They don't write across. They don't write into two languages at once. So they could easily, what they do is actually split the languages when they push it down to the slaves into independent connections. But the final one, and that's actually also the last one before I give up, is this one, because this is an idea. And who of you is using MySQL application? Just using MySQL application. Okay. Who of you has ever had a failed master? Half of you, basically. Okay.
Well, that's one reason why you use the application after all.
Because you want your master to fail?
No, because when the master fails, you switch on to the slave, right?
So if the master fails, what do you do?
Cry.
Okay, that's a good start. I think there's one other way to do it. I think MMM is doing that. Multi-master.
Does it do, it's like multi-master master management. Does it do automated failover, or does it use Linux HA?
That part is not so interesting. It's more interesting about getting a new master in there and how to tell your slaves there's a new master. So the failover part is not so
interesting.
But
that's easy.
Yeah. So but figuring out which of the slaves is a good slave that you want to promote to be a master, and then changing all the slaves and stopping the application to doing something, that's the trick part. Because that's the part where you can easily screw up, where some of the slaves may not be as current as they should be, and I have to pick one of them, and so on. So that's where management comes into play. And one way to handle it, and that's where I propose something, is putting someone in the middle who is only forwarding stuff, and you can easily switch out masters, so from one master to another, without actually having the slaves to be reconfigured to talk to a new master. So the idea here is, this is your setup. Here are your slaves. This is our magic application using MySQL Proxy in the middle, understanding bin logs. And these are your two masters. So you actually have one master, one standby master. They are using just circular application to actually update. Actually not circular, just ignore the first lane. So this is the way how it's replicated. So you insert into master number 1, it replicates to master number 2, which is our fallback, and to our proxy. And what the proxy does there in the middle, it waits for the bin log from the two sides to actually report the same information. So instead of being asynchronous all the way, we had a synchronization point here in the middle where we track, okay, this is the bin log event coming from my active master. Then I have a different way of the same information, and I wait until the information is arrived at both points. So now I know the second master, my fallback that will hopefully jump in if the first one dies, has the same information, and now I forward it to the slaves. So I add a bit of delay in between here, but this way I know my second master is always in sync. So I know that my slaves, that I don't have to pick any of the slaves underneath to which of the best, because I know this one is as good, the second one is as good as the first one. And if the first one here dies, I don't have to change any of the slaves because they always talk to my magic application here. And I just have to tell my application to talk to the other now active master. So by adding a bit of latency here, because we wait for those two servers to have accepted the same data, I make my replication more stable. So I wait a bit more. Instead of just being free-flowing all the way. The application doesn't matter, so it doesn't see a difference in it. It just creates a bit more replication lag, but that's it. But it gives me a more stable replication setup. It's easier to fail over. Yeah.
But the application should wait until they receive, two servers should receive the event, right? Or not?
No. This is still asynchronous replication, so it behaves as it's done.
But then, if it is asynchronous, then how do you know that two slaves are currently in sync? I mean, there is still a possibility of losing data if you have.
That's a different problem. It's not about the external view, because synchronizing those two is also easy if you have global transaction IDs, and that's something you can insert with MySQL Proxy if you want. So you can insert global transaction IDs so that way you can figure out if the two master and slave are in sync from the external side.
No,
this is more about failing over from one of the master dies without having to reconfigure all the hosts in the application.
I mean between master 1 and master 2.
Yeah.
How do you know that they are sync?
I only guarantee that those slaves underneath here,
Okay.
I don't make any entries to the application. I only guarantee to the low end side. Okay. If you have questions, the easiest way is writing me a mail at jan@mysql.com. I hope this mail address will work for a long, long time. I hope so.
If not, it will just forward to jan@oracle.com.
Yeah. Everybody interested. You can always find me on IRC. If you come to the MySQL-Proxy channel on Freenode, there's where I'm hanging out. The code for all this stuff is on Launchpad in the MySQL Proxy repository. There's a replication tree in there which contains all the stuff that we talked about. Okay, if you have more questions, I think we just do it after the little short break. Do we have a break or not?
Yes, we are.
Yeah, there's a break after every single one.
So if you have questions, you